Okay, so welcome. This is the third time I've recorded this video, so let's hope this time I don't accidentally delete it. Alright, so what we want to look at today is being able to detect if there's a deadlock on the board, meaning if there's no more matches. And in order to do that, so let's say that we have our board here, we need to be able to do a few things first. First, we need to be able to virtually switch any two pieces values on the board. And once we've switched those pieces values, we need to be able to then look through the entire board and see if there's a match on that new switched version of the board. And we need to be able to do that for every piece in at least two directions. We can be super diligent about it and do all four directions, or three or two, depending on which piece we're checking, but we need to be able to do that in at least two directions for every piece on the board. So let's say that we're looking at this piece right here. So this piece has three different actually six different possibilities of making a match. First, if we swipe it to the right, it could make a match by being the top of a match 3, meaning if these two pieces are the same as that piece. It could make a match by being the middle of a match 3, meaning these two are the same as that, or by being the bottom of a match 3. So there's three possibilities that this piece could be involved in a match right there. Next, this piece could be part of a match if we move it up, and it's say the right hand side of a match 3. We could move it up and it could be the middle of a match 3, or we could move it up and it could be the left hand side of a match 3. Now I don't need to look down or left if I'm looking right and up, because if I'm switching down, that's the same thing as looking for matches for this one here, and if I'm switching left, that's the same as looking for matches for that one there. So I really only need to switch each piece two directions, and just randomly I'm going to choose those two directions as right and up. I could go down and left, I could go right and down, I could go left and up. It doesn't matter, you just have to have two directions, one that's horizontal and one that's vertical. So I'm right-handed, so I like right, and up just sounds good. So we're going to switch right and up. Now we need to have a couple helper methods here. First, we need to have a helper method that switches values. So something to switch values. We need to have a helper method to find matches on this new version of the board. Find matches on new board. And we need to be able to combine these two together. Switch and find. And then we need to have our last little method here, which finds the deadlock. And this is going to be a Boolean value that is true. That is true if there are matches on the board, and is false if there are not matches on the board. So this is kind of a little framework for what we're going to do. Now once we have this done, then we can have another framework to be able to reshuffle all of these if there's no matches on the board. But first we need to be able to detect if there are matches. Also, once we can detect if there are matches, we can have it choose one of those matching pairs and give a hint to the user, you know, like have this one glow or pulse a little bit so the user can see that they can swap that there. Okay, so let's jump to the code and get started. Alright, so here we are. I'm going to do a couple things to my board really quickly just to make it easier to detect the situation where we would have a deadlock. First, I'm going to make my width and height something relatively small, so I'm going to go 5 by 5. Second, I'm going to make sure that all 8 of my possible dots are on the board here, because the smaller the board is with more pieces, the more likely it is to have a deadlock. And I don't necessarily want to have to be able to, or be testing the board for a million years to be testing if there's a deadlock or not. So first I'm going to go into my scripts, and it makes sense to me to be doing this logic in the board script. So I'm going to open up the board script, and I already have this up here and ready to go. So I'm down here at the bottom of the board script, and I'm going to start adding my little helper routines. Okay, sorry about that weird cut. So the first little helper routine I'm going to add is something to switch the pieces. So this is going to be something that doesn't have a return value, so it's just going to be a void. I'll make it private, void, and I'll call it switch pieces. And this is going to need a couple arguments. It's going to need to know a column and row, and that we're going to start with, and then a direction in which to make the switch. So I'm going to need an integer for the column, an integer for the row, and I'm going to use a vector 2, which is an xy coordinate, for a direction. Okay. So what I'm going to do here first is I'm going to take the first piece and save it in a holder. So what I mean by save it in a holder is I'm going to take all dots, actually declare this as a variable. So I'm going to do game object holder is equal to all dots column row. And I'm going to add that I'm saving this as a game object, because sometimes Unity gets a little persnickety when you try to save a something from a two-dimensional array into just a single object. So I'm just going to make sure it knows to save it as a game object. Next thing I'm going to do is I'm going to take all dots, and I want to do column plus whatever the x coordinate of this direction vector is. So in order to do that, I can't just add direction.x. And the reason I can't just do that is because direction.x by default actually is a float value. And if you add an integer and a float without specifically telling Unity to make the float an integer value, it thinks that there could be a decimal. And if it's expecting an integer, then it gets a decimal. It's going to freak out. So I need to recast this direction as an integer first. And you recast it just by adding parentheses integer in front. And I'm going to do the same thing for the row. So row plus integer direction.y. And I'm going to set this equal to all dots column row. So what I'm doing here is I am switching the first dot to be, actually, okay, I need to make a quick change here. So I want my holder object to be the second one, the way I'm doing this here. So in my holder object, I'm going to make this column plus the casted integer version of direction.x, and then row plus the casted integer version of direction.y. So I want to save the first piece, I want to save the second piece. And then I want to switch the first dot to be the second position. And then after that, I need to set the first dot to be the second dot. So I'm going to do all dots column row to be equal to the holder. All right. So again, just to kind of walk you through this, we're going to take in a column and a row, which is an XY coordinate on the board, and a direction that we want to switch. And we're going to create a holder object that's going to hold the one that we're switching with. We're going to move that first one into the second's position, and then we're going to take that holder and set it into the first one's position so that we've effectively switched the pieces. So that's our first helper method. The next helper method we want to do is we want something that's capable of checking for matches on this board and returning a Boolean value, something that's true or false. So instead of being a void, this is going to be a bool, and I'll call this check for matches. And this doesn't take any arguments because it's going to check the entire board. Now when you're doing something that isn't a void, if not all code paths return a value. You'll get this red line here. So what I like to do first is at the very beginning, just do return false. And that makes that go away. So what I'm going to do is I'm going to go over the entire board. So for integer I is equal to 0, I is less than width, I plus plus. And then for integer j is equal to 0, j is less than width, j plus plus. I want to first make sure that it's not an empty space. So if all dots ij is not null, because we have those empty spaces now. So if it's not an empty space, then I'm going to check right and up. So if I'm going to check right, I'm going to check that dot and 2 dots to the right. So I need to make sure that that dot, the dot to the right, and the dot 2 to the right all exist. So if all dots I plus 1j is not null, and all dots I plus 2j is not null. So I'm making sure that all of these exist. And since I'm doing that, I want to leave that way. Okay, so what I want to do now is, so let's comment this. Check if the dots to the right and 2 to the right exist. Okay, and then we want to check their tags. So if all dots I plus 1j dot tag is equal to all dots ij dot tag, and all dots I plus 2j dot tag is equal to all dots ij dot tag. So that means that there's a match on the board, so I'm going to return true. So that's checking to the right. Now I want to also check up. So I'm going to do if all dots I j plus 1 is not null, making sure that they exist first, and all dots I j plus 2 is not null, then I want to check their values. So if all dots I j plus 1 dot tag is equal to all dots ij dot tag, and all dots ij plus 2 dot tag is equal to all dots ij dot tag. So again, I want to check if the dots above exist, and then if they do exist and they have the same tags, then I'm going to return true. So this is just checking to see if there are any matches on the board. So it's going to return true if their tags match the first one, and it's going to return true if their tags match the first one both to the right and up. And okay, there's one more check I want to do here, and this is because I'm going from 0 to less than the width. So before I check if the dots to the right and to the left are, I want to make sure that going to the right isn't going to take me outside of the board. So make sure that 1 and 2 to the right are in the board. And so to do that, I'm going to say if I is less than width minus 1. So I'm only going to perform the check to the right. good lord. I don't know why my computer keeps doing this. It doesn't seem to understand what I want to do. There we go. All right, anyway. So before I perform the check to the right, I want to make sure that my I is less than width minus 1. Actually, I'm going to make that width minus 2. Because, let's say the width is 6. I want to be in the 4th row, which is really the 3rd row, which is 5 minus 2. I think maybe I want it. No, I do want it less than 1. Okay, sorry. Alright, cool. Now, here, I want to do the same thing here. I want to make sure that my row is low enough that I can go 2 up and not be outside of my my array. So if j is less than height minus 1, and then I want to, there we go. Okay, cool. So this is going to go through the entire board. It's going to look for matches, and if there are matches, it's going to return a true Boolean value. But if it goes through every piece on the board and it doesn't find a single match, it's going to return a false value. Because it's never going to reach this if it hits one of these. Then it's just going to exit the method, and it's going to return control of the program to whatever method called it. That's what return means, is it returns control of the program, or it returns this value. Okay, so what I want to do next is come up with a method to switch and check the pieces. So this is going to be a Boolean value. So private bool switch and check. And I need to know where I'm switching and checking and a direction to check. So integer column, integer row, and vector to direction. So what I'm going to do here is I'm going to switch pieces, and I'm going to switch them at the column and the row and the direction. And then I'm going to check to see if there are matches. So if check for matches, meaning, and if I don't put anything there, meaning it's true, then I'm going to switch the pieces back, column, row, and direction, and I'm going to return true, meaning there was a match on the board. If check for matches is false, then I'm going to switch the pieces, column, row, and direction, and I'm going to return false. So, it helps if I spell return correctly. So again, given one specific piece, I'm going to switch that with another piece in some direction, left, right, up, or down. I'm going to check for matches. If check for matches comes back true, I'm going to switch them back and tell whatever called this that it's true. If it doesn't come back true, I'm going to switch the pieces back and tell whatever called this that it's false. So well, that's my switch and check routine. So there are my 3 helper methods. One to switch the pieces, one to check the board for matches, and one to switch and check. And so now what I want to do is I'm going to create a Boolean value. I'm going to make sure that it's private. And I'll call this is deadlocked, maybe. Yeah, that's good. So it's going to return true if it's deadlocked. So I'm going to default it to return true. And it's going to return false if it's not deadlocked. So I want to go through every single piece on the board, and I want to switch it right and check, and then I want to switch it up and check. So I'm going to do for integer I equals 0. I is...
As Christian, I found Mrs. Bedford. She's in my classroom, my office. You can come find her here.
Okay, so I'm going to go for I is 0, I is less than width, I plus plus. And then I'm going to go for integer j is 0, j is less than height, j plus plus. Okay, so first I want to make sure that that position isn't null. So if all dots ij is not null, Then I want to, before I switch to the right, I want to make sure that I have the ability to switch to the right. So if I is less than width minus 1, then what I want to do is check, switch and check, and my column is I, my row is J, and I'm going to do vector2.right. So I'm going to switch it to the right. Actually, I'm going to use this to check. So I'm going to say if that is true, then I'm going to return true. Oh, nope, not true, but false, because it's not deadlocked because there is a match on the board. Okay, this is why I kind of saved this lecture for much later in the series, because this is complicated logic. Sometimes I don't even understand what I'm saying. Okay, so if I is less than width minus 1, and if switch and check ij vector2.right returns true, then I'm going to return false, that there is not a deadlock on the board. I'm going to do something similar for the height. So if j is less than height minus 1, and I only need to do 1 here, not 2, because I'm only going up 1, then I want to do if switch and check ij vector2.up, I'm going to return false. And if it goes through every single piece and switches and checks them, and it doesn't hit one of these requirements, then it's going to default to returning true. Now, all of this logic doesn't do anything yet in the board. All of these methods I made don't do a single thing yet. So to make them do something, I'm going to go to my fill board coroutine here, and I'm going to, right before I switch my game state back to move, I'm going to add another check. And that check is going to be for find deadlock. So we're going to say if is deadlocked? What did I call it? Yeah, is deadlocked. So if is deadlocked returns true, I'm going to add just a little debug statement. Deadlocked. Okay, so whenever we refill the board, we're going to check to see if we're deadlocked, and if we're deadlocked, it's going to print out a little statement that says deadlocked. It's not going to do anything. It's just going to print this out. Now, I'm not checking this at the start, so it is possible that I could get a board that's deadlocked to begin with, and it won't detect it, because I'm only calling this when we're refilling the board. So that is an issue to watch out for. I'm going to save my script. I'm going to pop back into Unity here and see if I have any errors. I don't think I do, but we'll find out. And okay, cool. So I'm going to hit play, and I'm going to play for a little bit. I might need to speed up the footage to see how long it's going to take me to find a deadlock. It's equally important, though, that the board doesn't return deadlocked if it's not deadlocked. And I have an issue. Board line 412. I'm pretty sure I know what that issue is. My index is out of range. Board line 412. Yep. These need to be -2. I was right the first time. And then this needs to be -2 as well. Okay, so back into Unity. If you guys didn't see what that was, it was my check for matches routine. If all.ij is not null, and then it needs to be width -2. If I is less than width -2, j is less than height -2. Otherwise, what happened was I got this index out of range exception error. What that means, index out of range, means that you're trying to pull something that is outside of the indices available for an array. So like if an array went from 0 to 5 and had 5 values in it, I might be trying to call the 10th value in that array. So that's what this error means. Okay, so I'm gonna try this again here. Again, I might need to speed up the footage, but let's test it really quickly here. It's equally important that it doesn't tell me I'm deadlocked if I'm not actually deadlocked. And I'm not deadlocked here. It's not telling me I'm deadlocked. So I'm going to swap my pieces. Still not deadlocked. So again, like I said, no, hey, I deadlocked and it recognized that. All right, cool. Let's try this again just to make sure. Again, I might speed up this footage depending on how long it takes. Oh, is it deadlocked right away? Yeah, it's deadlocked right away. Awesome. Okay. All right, so let's try this again. Okay, cool. All right, so my board isn't deadlocked and it's not telling me it's deadlocked. So swap the pieces. Not deadlocked. It's not telling me it's deadlocked. Swap the pieces. Still doesn't think it's deadlocked. There. It is deadlocked and it knows it's deadlocked. All right, cool. So that's how you, oops, I don't know why I did that. That's how you make sure that your board knows when there is and is not a match on the board. Next, we're going to talk about how to make the board shuffle itself when there is a deadlock, which is not too complicated. Now that we've got the actual core of the deadlock logic down, making it so that it shuffles the board and so that it gives a hint are both relatively easy. Okay, so if you want to follow me on Twitter to find out when I post a new video, I will put my Twitter link below. I'll also put a link to a Discord server below and a link to the GitHub for this project. I put it on Git because it's just easier than Google Drive, because every time you make a change to the folder, Google Drive changes the shareable link. So all that's going to be in the description down below. And yeah, have yourself a wonderful day.